This is the solution video for section 8.3, problem number 6. A solid has its base in the xy plane. Excuse me, in the xy plane bounded by the graphs of y equals 4, y equals x squared. Find the volume of the solid if every cross section by a plane perpendicular to the x-axis is an isosceles right triangle with the hypotenuse in the xy plane. All right, so first of all, we need to draw a graph. All right, so y equals 4, horizontal line, y equals x squared, parabola facing upwards, vertex at 0, 0. All right. All right. So we've got this region here, right? So all of this, right? But now we want to take a plane perpendicular to the x-axis. So that means we are using a dx cut, right? Because dx is perpendicular to the x-axis. Now, all right. Uh, it says that the cross section is an isosceles right triangle with the hypotenuse in the xy plane. So that means this height of the dx is the hypotenuse, right? So that means we are coming off the page here, right? And it's an isosceles right triangle. So this is our right angle. All right. So now if we take this and we lay it flat, okay, we've got this isosceles right triangle right here. And this represents the height of the dx. All right. And so now we want to think about, okay, first of all, how do I find the area of this triangle? Well, remember, the area of the triangle would be like 1/2 base times height, right? 1/2 base times height. Now, that would mean that like the height of the dx here is the base, and then the height would be here, right? Because these are perpendicular, right? So you can do that. Now, what we have to remember is that this is an isosceles triangle, right? So these angles are the same, right? And so if those angles are the same, then that means that this angle here and this angle here are the same, right? Because we cut that 90 in half, which means that the half of this is actually the same as that, right? Those two are equal, right? Um, I'm sorry, wait a minute. These are equal to each other, right? Because they're cut in half. They're not the same as that, right? That would be the hypotenuse of those. But then the altitude here is actually the same as those, right? All right. And so what we want to do is we want to recognize, well, if this is a isosceles right triangle, the base here is the height of the dx. So we're going to take the upper boundary, right? So I'm going to write b is upper boundary, which is 4 minus the lower boundary. And this is y equals x squared. So 4 minus x squared, right? That would be b, right? Now, what about h? Well, h is equal to half of b, isn't it? So h is half of b, or half of 4 minus x squared, right? And so that means the area then is 1/2 b, which is 4 minus x squared, times h, which is half of 4 minus x squared, right? And so if we simplify this a little bit, we get, you got a half and a half, so you got a fourth here, and then you've got 4 minus x squared times itself, right? So 4 minus x squared squared, right? So that's the area of this thing, right? So now we want to integrate the area of a cross section, so 1/4 4 minus x squared squared with respect to x from left to right. So left to right. Now remember, these points, right, are where y is equal to 4, right? Y is equal to 4. All right, so how do I find the x value, right? Because that's what we need to know. Well, when is x squared equal to 4? Well, that would be at plus or minus 2. And so this is positive 2, this is negative 2, and so then we are integrating from negative 2 to positive 2. All right, so now I'm going to bring the 1/4 on the outside, and then I'm going to integrate from negative 2 to positive 2, and I'm going to multiply out the 4 minus x squared squared. So that would be 16 minus 8x squared plus x to the 4th, right? And integrate with respect to x. All right, so I've got the 1/4. Now, integrate, I get 16x minus 8x cubed over 3 plus x to the 5th over 5, and then evaluate that from negative 2 to positive 2. So I've got the 1/4 in front. All right, so now I've got 16 times 2 minus 8 times 2 cubed. That's a 3 over 3 plus 2 to the 5th over 5, right? And then minus 1/4, 16 times negative 2 minus 8 times negative 2 cubed over 3 plus negative 2 to the fifth over 5, right? And so now I just have to simplify that. Now I know that's annoying, but that's what we have to do. All right. And so we've got 1/4. All right. I've got 32 minus 8 times 3 cubed. So that's 8 times 8. So that's 64 cubed plus 32 fifths, right? And then minus 1/4. And then I've got negative 32. And then I've got negative 8 times negative 2 cubed. So that'd be plus 64 thirds. And then here minus 32 fifths. All right. And so now I'm going to keep the 1/4 on the outside for now. And then I've got 32 minus negative 32. So that's 32 plus 32. So that's 64. I've got a negative 64 thirds minus a 64 thirds. So that'd be minus 128 thirds. And then I've got a 32 fifths minus negative 32 fifths. So that's going to become 64 fifths, right? And so now I just need to work on this, right? I've got, let's see. All right. All right, so I'm going to leave the 1/4 on the outside. All right, so now I need a common denominator. So 64 times 15 over 15 minus 128 times 5 over 15 plus 64 times 3 over 15. All right, so now 64 times 15. I know that this can be annoying. All right, so 64 times 15 is 960. All right. Actually, let's do this. I can make this a little easier, and I've got the 1/4 here. So let's reduce 64 divided by 4 is 16. 128 divided by 4 is 32. 64 divided by 4 is 16. So we can make the numbers a little easier. All right. And so I've got 16 times 15. So 240 fifteenths. All right. And then minus 32 times 5 is 160. And then plus 16 times 3 is, of course, 48. And so 240 minus 160 plus 48 gives me 128 fifteenths. All right. And so that would be the volume that we get for problem number 6.